Hi, second year students, let's complete exercise 3.7, the definite integral, the last three questions, last but not least, good questions, giving good idea of biparts as well as partial fractions. Let's see and find out without wasting time. Our limits runs from O to pi over 4, tan inverse y dy. Let's write once again the famous eyelet rule for biparts. Through eyelet, we select the first one. If the choice of first one is good one, then integration by parts is a walk in the park, a piece of cake. Otherwise, it is not going to compress. It keeps on expanding and almost a disaster for you. I stands for inverse, L for logarithmic function, A algebraic, T trigonometric, E exponential. We are familiar several times. How to generate second one? We have the helping hand into one. First, that's our U, that's our V. Tan inverse, first same integration of second. If we want to integrate tan inverse, we don't have integration of tan inverse. Ask yourself, tan inverse is differentiation of something? Definitely the answer is no. That's why it has to be taken first, or according to our rule, eyelet rule, inverse priority, number one to be selected for the first one, then logarithmic, algebraic, trigonometric, and eventually exponential. U integration of V minus whole integral derivative of first, that is our differentiation of tan inverse of y with respect to y, and integration of second dy. Let me integrate the limits. In the end, we are in a position to apply limits. Tan inverse y, integration of 1 with respect to y is y minus differentiation of tan inverse is 1 over 1 plus y square. Integration of second is y dy. They can't multiply to separate functions. They can be written in that manner. Y times tan inverse y minus, look at this, differentiation of y square is 2y. Differentiation of y square is 2y. Function derivative works wonder for us. Function derivative work wonder for us. There is deficiency of 2. Divide and multiply by. Divide and multiply by 2 1 plus y square overall power 1. I am writing for you in order to give you good clarity. Derivative function in the denominator having overall power 1. It's a situation of ln y times tan inverse of y minus 1 over 2. That's ln whatever is with whatever the function present in denominator, it's our answer, with ln plus c upper limit as well as lower limit, that are 0 to pi upon 4. Don't forget to put upper limit minus upper limit. How I heard it m. Upper limit minus lower limit. What's our upper limit? Pi upon 4. Pi upon 4 instead of y. Tan inverse of pi upon 4 minus 1 over 2. ln 1 plus y means pi upon 4 square plus c. That's our upper limit. That's our upper limit minus lower limit. We have O times 0 times tan inverse of 0 minus 1 upon 2 ln 1 plus 0 square plus c. That's overall 0. ln 1 is also 0. Here remains c cancelled out, and we are left with what? Let's see and find out. Pi upon 4 same. Pi upon 4 same. Tan inverse of pi upon 4. Angle 45. There is tan inverse of pi upon 4. Tan inverse of pi upon 4. Tan pi upon 4 is 1. Let me check the limits in that case. Are limits good in that question? Pass me the book. 10 pi upon 4 is 1. 10 pi upon 4 is 1. What about tan inverse of pi upon 4? What about tan inverse of pi upon 4? Let me check the limits. 3.7. 0 to pi upon 4. Tan inverse of pi upon 4. Yes, pi upon 4 times tan inverse of pi over 4. It is something baffling, perplexing. Tan inverse of pi upon 4, don't jump to conclusion that it is equal to 1. No, no. Tan inverse of 1 is equal to pi upon 4. Tan inverse of 1 or tan of 1 is pi over 4 or 45. That is tan inverse of pi upon 4. That's tan inverse of pi upon 4. It is some sort of digital calculator to be utilized here to get at the result, or minus 1 over 2. It is our ln. Square of pi is pi square. Square of 16 is 4 is 16 plus c. Square of 64 is 16 minus it's 0. ln 1 is 0. Here remains plus c and minus c. They are cancelled out. Utilizing this thing here, I have pi over 4 tan inverse of pi over 4. Calculator should be required here, or it is some sort of error they have given. But let me sort out the question. ln, taking LCM 16 plus pi square, overall 16, and it's our answer. It's our answer. It's a blind spot of us. It is blind spot of this question. What they have done, you can leave here or utilize any property of log. It can also be written as pi over 4 times tan inverse of pi over 4 minus 1 over 2 ln, utilizing tiny property of log, 16 pi square minus ln 16 here it's minus 1 over 2 to be multiplied here to get somewhere, or you can leave your answer here. Such type of techniques they are helpful for solving differential equations, especially boundary and initial conditions. With initial and boundary conditions, it works wonder over there. ln 16 plus pi square minus plus 1 over 2 ln 16 leave here, or one can switch over 1 upon 2 there, 1 upon 2 there. It can also be written as pi over 4 tan inverse of pi over 4 minus 1 upon 2. Sorry, this coefficient can become power. Let me write under root for 1 upon 2, 16 pi square plus ln under root 16. Under root 16 means ln 4. Under root 16 means ln 4 in next step. We have pi upon 4 tan inverse of pi over 4 minus ln 16 plus pi square plus ln 4 plus ln 4. It's our answer. It's our answer. By the way, in your book there is given only pi upon 2, pi over 2, and there is nothing. There is nothing. There is nothing. This question demands further investigation, but I am sure it is their mistake in the limit. There is tan inverse. There is tan inverse. There must be some numerical value 0, 1, 0 root 3, 0 to 1 over root 3, because it is tan inverse. Because it is tan inverse. The standard value for tan are 0, undefined, 1, minus 1, root 3, 1 over root 3, 1 over root 3. They must be given there. They must be given in this limit. Or accidentally they have given pi upon 4. It's a letter matter. They will rectify their mistake, and I have pointed them. Moving towards question number 2, 0 to pi over 2. It's a good question. It is a standard question. Such type of questions are present in our Sakhar board, Sindh board books. 2 to 3 questions. They have given one, and I like this very much. It's a partial fraction case. How to reduce to partial fraction? over 2 pi over 2 sin x dx, 2 plus cos x, 5 plus cos x and dx. Look, there is normal sine case, sine and cos, they have given normal angle. Look, if there is inverse, there must be a numerical value, 0, 1, 0, minus 1, 0, root 3, 0, 1 over root 3 or 0 to infinity. They can do this. Okay. Here, it's a partial fraction case, just assume that y is equal to only cos x, differentiate with respect to x, dy over dx, differentiation of cos is minus sine, shift differential dx here, differential y is going to be minus sine x dx. We are interested in only value of sine x dx, multiplying minus throughout, we have minus dy is equal to sine x dx. Utilize these two assumptions in the original integral. We have something like 4 to pi over 2, instead of sine x dx, minus dy over 2 plus y and 5 plus y. This is our simple partial fraction, as the degree of denominator is greater than numerator and there is no function derivative situation, and both brackets are linear as well as different. Linear and different roots. They can be split up in partial fraction as a over 2 upon y plus b over 5 plus y. Don't forget to take this minus 1 over 2 plus y times 5 plus y. Let me manage this a. It's our a. Okay, taking LCM, we have a times 5 plus y, b times 2 plus y, and denominator is 2 plus y times 5 plus y is equal to minus 1 over 2 plus y times 5 plus y. Shift 2 plus y times 5 plus y here, they can be cancelled out, save our soul from industrious work. A times 5 plus y plus b times 2 plus y is equal to minus 1. Multiply and compare the like terms, it will become 5a plus ay 2b plus by is equal to minus 1. Collecting the like terms and finding the value of capital A and B. This is first y, ay plus by, then constant 5a plus 2b is equal to negative 1. Taking y common, a plus b is plus 5a plus 2b is equal to 0y minus 1. 0y minus 1. I have generated y here with the assistance of 0. Compare the like terms. Coefficient of y power 1 is equal to y power 1, means a plus b is equal to 0, and second one is constant 5a plus 2b is equal to minus 1. 5a plus 2b is equal to minus 1. If I manage value of a from here, a or b, a is equal to minus b, insert here, plug in here, 5 times minus b plus 2b is equal to minus 1, minus 5b plus 2b is equal to minus 1. Then we are left with minus 3b, 3b is equal to minus 1, or b is equal to positive 1 over 3. b is equal to positive 1 over 3. b is equal to positive 1 over 3. Okay. From this, a is going to be minus 1 over 3. b is 1 over 3, a is negative 1 over 3. Utilize the values here. It will be a times dy over 2 plus y plus b dy over 5 plus y. A is minus 1 over 3. It's famous case of function derivative having overall power 1. Function derivative, overall power 1. It is situation of ln. Whatever is present in denominator, it's r in it's with ln. B is r 1 over 3. Same situation prevails here. 5 0, differentiation of y is 1. Function derivative, function is in denominator having power 1. It is another situation of ln 5 plus y plus c. Making life simple, I am writing the first positive 1 over 3, then negative in order to compact them, utilizing the tiny property of log 1 over 3 ln 5 plus y minus 1 over 3 ln 2 plus y plus c. Don't forget the limits. 1 over 3 common. We are left with ln 5 plus y minus ln 2 plus y plus c and the limits. Ln a minus ln b. Ln a minus ln b. It can be written as ln 1 over 3 ln 5 plus y overall divided by 2 over y. 2 plus y plus c and the limits are we have limits are in that case 0 to pi upon 2. 0 to pi upon 2. Don't forget we have utilized the assumption y is equal to cos x. Instead of y insert cos 5 plus cos x, then 2 plus cos x here plus c. Upper limit is pi over 2, cos pi over 2 is 0, cos 90 is 0, 1 over 3. We are left with ln 5 plus cos pi over 2, 2 plus cos pi over 2 plus c, then minus upper limit minus lower limit, upper limit minus lower limit. Our lower limit is 1 over 3 ln 5 cos 0 is 1, 2 plus cos 0 and the plus c. Multiplying minus throughout, cc cancelled out. Here it is 5 plus 0, 2 plus 0. We are left with ln 5 over 2 only. In that case, plus c minus 1 over 3. Ln 5 plus 1, 6. Ln 5 plus 1, 2 plus 1 minus c. Minus plus minus c cancelled out. 1 upon 3 common. Here we have ln 5 over 2 minus ln 6 over 3. 6 over 3 means 2, utilizing the tiny property of log. 1 upon 3 ln 5 upon 2. This 2 also in ln. It will become 1 upon 3 ln 5 over 4. It's our answer in that case. Its answer here remains ln 2, utilizing the tiny property of log. Ln a minus ln b, they can be written in a compact fashion as ln a over b, ln over b. Here I have 5 over 2 already. This 2 is also coming in the denominator. It will become 5 over 4. It will become 5 over 4. Or one can utilize still property of logarithm. Power can be converted to coefficient. Log of 5, cube root of 5 over 4. Log of 5 over 4 and cube root. Final answer. Eventually moving towards question number 20, final question of this exercise. Simple question based on partial fraction. The factors are linear repeated. Let's see how. 4 to 5, 0 to 5, 2 to 5. Oh God, dx over x times x plus 1. Look, it is not function derivative situation, not function derivative situation. And here the two brackets having power 1 and they are different. Linear and different. Without wasting time, resolve into partial fraction. A over x plus b over x plus 1 is equal to 1 over x times x plus 1. Taking LCM, it will become a times x plus 1 plus b times x overall. X times x plus 1 is equal to same original integral 1 over x times x plus 1. Cancelled out as we move from left to right, from denominator to numerator, from division to multiplication. Multiply x plus a plus px is equal to 1. Collecting the like terms, ax plus bx plus a is equal to, let me manage the x, that's 0x plus 1, x common, and comparing the coefficients of same powers. X times a plus b plus a is 0x plus 1. Coefficient of x is equal to x. Coefficient of x, a plus b is equal to 0. From here, constant is equal to constant. So value of a is 1. Putting here, 1 plus b is equal to 0. So b is equal to minus 1. A is 1, b is minus 1. A is 1, b is minus 1. Managing here, and it's a situation of ln, just put the limit and get along. We have a is 1 times dx over x plus 1, and b is minus 1 dx over x plus, it's x only, x, a over x, a value of a is 1 dx over x, value of b is minus 1 dx over x plus 1. It is tiny situation of ln x minus plus minus ln x plus 1 plus c. We have some limits. Make it second, compress this term, utilizing tiny property of log ln x over x plus 1 plus c. Limits runs from 2 to 5, 2 to 5. Upper limit minus lower limit, upper limit minus lower limit, something like ln 5 over 5 plus 1 and plus c minus ln 2 over 2 plus 1, and here plus c as well. Simplifying, just multiply this minus and writing them after utilizing the property of log. We have what? Let's see and find out. It will become ln 5 over 6 plus c minus, it will become ln 2 over 3, ln 2 over 3 plus minus minus, that's c cancelled out. We are left with ln 5 over 6 minus ln 2 over 3. Shrink these two terms utilizing tiny property of log, write them in second form, ln 5 over 6 dividing with 2 over 3. 2 over 3. We have ln 5 over 6, that is 3 over 2. Applying property, applying table of 3, we have left with ln 5 over 2 times 2, means ln 5 over 4 is our final answer in that case, is our final answer in this case. I have utilized the tiny property of log, that is ln a minus ln b can be written as ln a over b, Instead of this upon, I have utilized division in order to facilitate our calculation. For calculation, convert this division into multiplication, taking the reciprocal of this one or multiplicative inverse of this one, reciprocal or multiplicative inverse, reciprocal, it will become 3 over 2. Applying table, we are arrived at the result, that is ln 5 over 4. It's our final answer of this exercise. We have just compiled exercise 3.7. Despite all odds, the journey must continue. Let's see and find out what exercise 3.8 have for us. It's all by itself next.